Hi, my name is Grant, and thank you for watching the Linear Actuators Common Controller Product Seminar. Today I'm going to be discussing in detail the features and benefits of the common controller featured in the EZ2 series product lineup. For the EZS2, the SPV, the EZC2, the EZA, and as well as the PWA2 series all utilize the same common controller. Now this controller can either be set up as a stepping motor driver or a built-in controller stored data function. It will utilize either the EZT1 teaching pendant or the EZ82 software. The benefit and advantage of sharing a common controller would be in a factory environment to reduce the amount of inventory needed as a backup or spare. So this is a great feature that is shared amongst all of these different linear actuator products. For the controller mode, it is capable of storing up to 63 different motion profiles. Now on these profiles you can set speeds, accelerations, deaccelerations, and so on. It has the ability to either do direct teaching or indirect teaching by utilizing, again, the teaching pendant or the software. For the manual teaching, you can physically move the table or the cylinder into place and then store that profile or position. For the remote teaching, you would simply jog it into place by using the pendant buttons or the software jogging function and then store the information into place. The other way to doing it is simply manually entering in all the data or positions and speeds yourself. And again, for the driver mode functionality, this is simply acting like a stepping motor driver. We would simply send a pulse and direction signal based on the resolution of the product. Controller mode versus driver mode. When using controller mode, there are a number of different functions that are not possible to use in driver mode. Some of those functions, for example, are the teaching function, the monitoring function, the area output function, the push motion function, and which we'll discuss in further detail in just a few moments. Some of the parameters or the common functions that they do share will be an absolute type system setup. Sensorless return to home is possible, and a return to home using sensors. One note, to set up a return to home using a sensor, you do need to set up some basic parameters using, again, the software or the pendant. So the motion profile capability. Basically, there's going to be two types of positioning data settings, and that's going to be either an absolute move or an incremental move. For an absolute move, we would picture a number line. For example, if we were told a system to move to absolute 50, it would move to the 50 on the number line. If you told it to move to absolute 50 again, it wouldn't move since it's already at that position. For incremental moves, if we did increments of 50 and told it to move incremental, it would move to the 50 position. If you gave that command again, it would move to the 100 position, and then to the 150 position, and so on. There's also two types of data execution modes. There's either selective positioning or sequential positioning. Now, selective positioning is where we actually use the M0 through M5 inputs. We can toggle through these inputs using a binary type switching scheme to specifically call specific profiles. For example, if M4, M3, and M2 are all activated, we would execute profile number 26. Now, sequential positioning, you do not have to use the M0 through M5 inputs. You can simply leave those all on the off position. And what would happen is you would start from the first sequence and sequentially move down through all of the different sequences that are programmed in using the software or the pendant. As those sequences execute, when we come to the last sequence that is programmed, or the number 63 sequence, upon executing that sequence, it would simply start over again to the first sequence. And that's what is mentioned, or that is what is meant by sequential positioning. For the motion profiles, we have what is called linked operation. With linked operation, we can select up to 4 points that can be linked together with different speeds. So in this example, we can see that we have our first point, and to move to that first point, we would operate at this first speed. And then to move to the second point, we can operate at a second speed, and basically change speeds on the fly, and it's all going to be in one fluid motion. We also have the area output function. As the table or the cylinder goes between 2 set points, once it's entered into that region, we can then output an output to tell another piece of equipment to perform a certain function, or to let the controller know that it's reached a certain point. We also have what is called the push function. The push function is a way of limiting the amount of force that is exerted by the actuator or the cylinder. We do this by limiting the amount of output torque from the motor. Once it reaches that set amount of output torque, it will then output a T-up output. Once that output can be used to tell the master controller to perform some other function or to stop motion, but it's a great way of actually limiting the amount of force that you can output from this actuator. Another useful feature of the push function is you can push up against an object for an indefinite amount of time and hold it in place. There's also 2 types of homing functions. The sensorless home detection. This is simply, again, utilizing a similar feature similar to that of the push function by detecting hard limits and then returning to home in this method. The other one is returning to home by using physical sensors. Now, we do offer optional sensor sets for certain products, and some products, sensors are actually included. For the optional product, we do provide means for mounting those sensors built into each actuator. Now, there's basically 3 different types of return to home. We can either do a 2-sensor operation, which uses 2 limits. We have 3-sensor operation, which uses 2 limits and a home sensor. And then we also have the sensorless operation. Now, the user, utilizing either the software or the pendant, can change the return direction when using sensorless or sensor homing by using the software or the pendant. You also have the ability to program in a home offset. So once you've reached the home sensor or the home limit, we can then program in a specific amount of distance to offset by. We also offer an absolute type option. By utilizing a separate PAEZ battery pack, we can then hook up the battery pack to maintain position at all times, even during a power down event. Since the position counter is stored in volatile memory, this battery pack ensures that that information is stored in the event of losing power. Another thing I'd like to note about this common controller is the controller key. Each actuator is going to come with its own controller key. This controller key contains information such as the motor size, the amount of current it requires, the physical stroke of the actuator, and other common parameters. Now, these parameters are then loaded into the controller to automatically adjust for different actuators. So if you have, for instance, 2 AC input type actuators, say 115, you could use the same type of controller between the 2 actuators, again, lowering the amount of inventory that one might have to keep in hand. Now, again, we've noted the EZ-T1 teaching pendant and the EZ-ED2 software. They both perform the same function. However, one will have an advantage over the other, and it really comes down to the type of setup that you prefer. It's really a preference thing. They both perform the same function. The only thing that the pendant can do that the software can't do, the pendant is equipped with an emergency stop button, and then the software is capable of having stored programs onto a PC, which you can put into a text file to save at your convenience. That is not possible with the pendant. So it really comes down to user preference to which one is more suitable for your setup. At this time, I'd like to go over some of the features of the EZ-ED2 software. So before you're going to see the main screen of the EZ-ED2 software. I'm currently connected to a device, so I'd like to go through each section to give a better explanation of what all these functions are for. The main screen under the data heading is the operation data. This is where we're going to input all of our general information, such as speeds, distances to move, and acceleration profiles. You can simply click into the field and enter in information. For the acceleration, we have 4 different profiles to choose from. For positioning type, we can either choose between an incremental type move or an absolute move. The position data is going to be in millimeters, and the positioning speed is going to be in millimeters per second. Now, there's 3 different operation types. We have a single move. We also have the capability of doing a linked move. That's where we're linking 2 motions together. And then we have the push motion function. When doing a push motion function, we set the push current in this column here. Under the parameter setting, we can look at some detailed information about the I/O. We can set things such as the action to take upon the stop input being activated. We can do a soft stop. We can do a hard stop. And then we can turn on and off magnetic brakes if using a magnetic brake type. We can set a stop logic input level. For the home and preset, we can switch between a home or a preset. We can enable and disable limit sensor detection and also change the limit and home sensor logic levels. Upon over travel action, we can either come to a hard stop or a soft stop. Under the motor parameter, we can set the operating current, the standstill current, the speed filter, and then the end width, which is the end signal. For the home parameter, we can change the direction that it returns to home, towards the motor or away from the motor. We can put in a home offset. We can also have a couple of different home types to choose from. 2 push functions and either a 2 sensor or a 3 sensor return to home. We can set a common operating starting speed and then a homing operating speed for return to home moves. Under the speed parameter, we can set a common starting speed, and then we have, again, 4 different acceleration profiles to choose from, each with its own accel and decel setting. And then we can also set a common operating speed. Now, the common starting and operating speed are going to be beneficial for when jogging the unit into place. Under the common setting, we can set enable and disable the software limits. So we can set soft limits, an upper and a lower soft limit. And again, that's going to be an electronic limit. We can also set an area. Again, between area and area 2, when the actuator has reached that specific distance, it will output the area output. Under the monitor, we can view the status, the actual position. We can also look at the physical outputs. We can also see if there has been an alarm event and check the alarm history. When I've clicked the Start Monitor button, we've physically connected in real time to the controller. Under the waveform, we can physically view a move. Now we can look at things like the actual speed versus the commanded speed. Then we can check things like limit sensor detection or end output, which is when the actuator physically stops moving. And we also have the test heading. Under the test heading, we can physically check the I/O. Again, once I click onto this, I will enable the test function to begin, and then I can monitor the outputs and the inputs. I'm going to physically push on a start input. Again, by dechecking this box, I've disconnected it from real-time communication. And then finally, we have an operation test. I'm going to enable to be able to test. And again, I'm connected back to the unit in real time. Now, I can do things like jog it into position. I have a minimum distance of 5 millimeters set. By clicking the plus button, the table is going to move, or the actuator is going to move forward the positive direction in increments of 0.5 millimeters. I can run continuously in the low speed, which again was set to 6 millimeters per second, or I can run continuously in the high speed, which was set to 100 millimeters per second. Note, we take measurement of the actual position. Because these are closed-loop stepping motors, there's resolver feedback, which determines the actual feedback or position of the actuator. By clicking on the home operation and clicking OK, it will begin a sensorless return to home. And I can also perform actual profiles by clicking on the position operation and clicking OK. I've now moved to the 150 millimeter position. I can do things like turn the motor current on and off. The motor excitation will be stopped. Okay. Now I can physically move the table into place. You can see that the actual position is moving because I'm physically moving it with my hand. Turning the motor current back on. Back to the 150 millimeter position. And now I'm going to perform a return to home. So the software is very simple to use. One thing I also want to point out, we are capable of connecting more than one drive together, and you can see down here we have an axis ID. This axis is 0. We can also do a teaching operation from the main screen, which is very similar to what we just did with the test, except this time we can set, by teaching and jogging it into position, we can set the position data by clicking on this button here. I'd like to thank you for watching this video today. If you do have any questions, feel free to give us a call at 1-800-468-3982 or email us at techsupport@orientamotor.com. My name is Grant, and thank you for watching.